Today in class in geometry, we reviewed about what we talked about yesterday, which was trig ratios. So when I talk about trig ratios, I am going to be talking a lot about, not rations, but ratios. I'm going to be talking a lot about SOHCAHTOA. And when I talk about SOHCAHTOA, I'm talking about sine, cosine, and tangent. And these are the three trig ratios we're going to talk about now. We'll get to some later on in the semester or in the year. So when I talk about SOHCAHTOA,
Mia Turner, you're needed at the front desk.
SOHCAHTOA. And this is just my acronym that I use to remember the ratios or between the trigonometric functions and the angles and the side measures. So the S stands for sine, the C stands for cosine, and the T stands for tangent. And O means opposite, H means hypotenuse, A means adjacent, and these are all related to sides. Again, H is hypotenuse. And then O again is opposite and adjacent. And somebody today in class mentioned, oh, that's why you mean sine is related, so the sine of an angle A is their relationship to the sides of a right triangle are opposite over adjacent. And I'm going to abbreviate. And what this means is I have a right triangle, okay, and it only relates to a right triangle, and I have angle A here, and I'm eventually going to have angle B and angle C. But angle A, the side opposite, is this side, right here. The hypotenuse, of course, is the side opposite and always will be the side opposite the 90-degree angle. And then the adjacent side to A is the one that the other side of the ray that touches the vertex A. So, and then cosine of A is going to be adjacent over hypotenuse. And then tangent of A is going to be opposite over the adjacent side. And we went a little further today and yesterday, and we went ahead and we established some relationships. So to talk about those relationships, though, I'm going to have a triangle, and I'm going to label this A, C, and B. My hypotenuse is going to be 5. One side is going to be 3, and the other side is going to be 4. And so I can put some numbers to what I'm talking about with this. So sine is going to be, so sine of A, and I always have to tell you which angle I'm talking about because it's going to determine what the relationships are, the ratios are. So sine A is the side opposite, the side length opposite, over the hypotenuse. And so this is the hypotenuse in this case, and in the other case too, of the angle B and C. So, and then cosine of A is going to be the side adjacent, so that side length would be 3 over 5. And then tangent of A is going to be opposite, which the side length of that is 4 over the adjacent side length, which is 3. So these are my ratios given this right triangle and talking about angle A.
Attention students with Mia Turner, please report to the front desk immediately, please. Mia Turner, your ride is waiting for you. Please come to the front desk.
We're going to talk about the other angle, which is B. So I'm going to be talking about this angle right here. And so the opposite to this angle, which would be 3. And then my hypotenuse is still 5. And then the cosine of B is going to be the side that's adjacent, and then my hypotenuse of 5. And then tangent of B is going to be my side opposite, which is 3, over my adjacent side, which is 4. Now, on page 7 in your packet, we talked today and we talked yesterday a little bit about how these two relate to each other. And we talked about how angle A and angle B are complements, because they add up to, so the measure of angle A plus the measure of angle B add up to be 90 degrees. So we call those complements, because they're complementary. So if you hear me talk in class about angle B is the complement of A, that means I add them together and they're going to be 90 degrees. So in this case, you can see a couple of different things. I can see that the cosine of A is actually the same as, or the sine of A is actually the cosine of B. The same ratio, 4 over 5, 4 over 5. And here you can see that the cosine of A is the same measurement or the same relationship as the sine of B. And then you can see that there is a relationship that goes on at the tangents of the complement, and that is that they are the reciprocal of each other. And this is going to be really, really, really important later on when we start putting some numbers with these. So what this means is that the sine of 30 degrees is going to be the same as the cosine of 60 degrees, because 60 is the complement to 30. What this also means is the cosine of 80 degrees is equal to the sine of 10 degrees. And you can establish all of these different relationships, and they're going to help you later on. Going a step further, if I know the tangent of an angle of A is going to be 1/2, I know that the tangent of the complement, which would be B, would be 2 over 1. Or if I knew the tangent of A is 3/4, like it was before, I know that the tangent of B is going to be 4/3, which is just kind of opposite of what it was up there. So I wanted you to see the relationships between the sine and the cosine of the complements. That will help you. So looking at some of your work that you did today in class, we can go ahead and look at this and see that we're on page 8 now. I'm sorry, we might be on page 10 now, pardon me. We can see that the sine of C is going to be the opposite over the hypotenuse. So sine of C is equal to 30 over 50, and I can simplify that to be 3/5. Here, the cosine of C is going to be the adjacent, which is 24, over 20, well, it looks like 26, so it would be 12/13. The sine of Z in this problem is, I'm looking at Z, the sine is opposite over hypotenuse, and that's going to simplify to 3/5 again. Cosine of Z is going to be the adjacent, so it's 30 over the hypotenuse, which is 50, so that's 3/5. The cosine of C, so I'm looking for adjacent, which is going to be cosine of C, adjacent, which is 40, over the hypotenuse, which is 41. So you really have to make sure that you're labeling these correctly. And the hypotenuse would be 41 in this case. And then again, the cosine of Z in this case is adjacent, which is 21 over 28, and so that's going to be 3/4 simplified. So that gives you an idea. Now, down below on number 7, you can see the sine of 80 is going to be congruent to the cosine of 20. The cosine of 37 is going to be congruent to the sine of 53. And then the cosine of B is going to be congruent to the sine of A. And that relates to our relationships that we just talked about. Now, taking it one step forward in what we did in class today, we worked this out together. is you can look at this, and we weren't even using a calculator, finding any numbers yet or anything. We were just looking at our ratio. So we noticed that x is going to be the opposite and 13 is going to be the hypotenuse. And you look at your SOHCAHTOA. So which is sine is equal to opposite, which is x, over hypotenuse, which is 13. Looking at number 2, I can see my angle is 32 degrees, and I have the opposite and the adjacent one. So tangent of 32 is opposite, which is 71, over adjacent, which is x. So that'll help you do some of your homework tonight.